Alright guys, so in this problem we're trying to solve the general expression for P for given this entire thing right here. So as we discussed in class earlier, since this is the Biot-Savart law and we have to find the delta S time cross R hat, we know that this right here and this right here won't actually have any effect on P because this is part of the line of charge and there's only charge around it, not necessarily the magnetic field will be around it, not necessarily on it at all. So the only thing that we'll be able to get it from is this arc right here. So to simplify the expression, we could just get B equals mu naught I over 4 pi I delta S over R squared. So now that we have this expression, we need to integrate a ds to find the general expression for point P right here. So what we get now is B equals mu naught over 4 pi times I over big R squared, which is basically the same thing as the radius from P, times the integral of ds of the arc. The reason we're doing the integral of ds is because that's arc length. So we have this now. I'm going to make a little more space. Now that we have that, we can see that we'll get mu naught I over 4 pi times IL over R squared. And we know that the arc length itself is just R theta, right? Because that's kind of a given right there. So L equals R theta, and once we simplify all of that, we should be able to get mu naught I theta over 4 pi R. And that should be the general expression to find the charge right here. The magnetic field at point P. So this is part A. So now that we have part A, they're now asking us if we substitute data as 2 pi, will it agree with the magnetic field of current of a loop? Let's see what happens. So the equation we had that we derived for point P was mu naught I theta mu naught I theta over 4 pi R squared, or excuse me, 4 pi R. And they're asking us if we replace theta with a 2 pi, would it be the same thing as a magnetic field of a current loop? So let's substitute that in. So we get mu naught I 2 pi over 4 pi times R. So pi's cancel, that cancels out to 2. So you get mu naught I over 2R. And mu naught I over 2R is the same expression as a one-turn coil. So yes, it does agree.